Let's talk about how to reverse a singly linked list. So in this example, I have a singly linked list with 3 nodes in it. The first node has a value of 1, the second node has a value of 2, and the third node has a value of 3. The head of this singly linked list is pointing to the node with value of 1, and the tail of this singly linked list is pointing to a value of 3. Okay? So the goal of reversing the singly linked list is to have at the end a linked list that looks like this. So notice how when we started, 1 points to 2, and 2 points to 3, and 3 points to null. And we've got it reversed in the final reverse linked. So 3 points to 2, 2 points to 1, and 1 points to null. And also notice how head used to point to node number 1, now head points to node number 3. And the same is true with tail. Tail used to point to 3, now tail points to 1. So this is what we're trying to get to. So this is our endpoint, and this is our starting point. Okay, so just keep that in mind. So I have some pseudocode over here that we'll be using to help us traverse, or in other words, move through the linked list one node at a time and perform operations to flip the locations or the directions of the arrows, essentially. Okay? Now, before we start traversal, we want to set up some initial conditions. And what we're going to do to help us keep track of everything is to use some pointer variables. So we're going to initialize some variables. I'm going to call them pointers because they are pointing to different values. Okay? And we're going to be, during our traversal process, we're going to be updating those values on the pointer variables to point to different values in our single linked list to help us keep track of everything. And you'll see that as we walk through the example. Okay, so the first 2 steps are setting up our initial conditions. So the first step is to set the previous and the next pointer to null. Okay, so I have this here that's going to represent null, the value of null, and we want to put our previous and next pointers and set those equal to null. So this is how I'm gonna set this up. So here, this is my variable. I called it previous, so this is my previous pointer, and this is my next pointer. Okay, and both of these are pointing to the value of null. So in the code, you'll see like previous equals null, and next equals null. Okay. Now, the last thing we want to do before we start a traversal is to set current to head. So this is going to be our third pointer variable, and we're going to set that to point to the head. And head points to the node 1. So both current and head are pointing to the node with value of 1. Okay, so now we can start a traversal process. Okay, so the first thing we want to do is, of course, we want to evaluate the condition. So we want to traverse the singly linked list while current is not pointing to null. Okay, so this is true. Current is not pointing to null, it's pointing to the node with a value of 1. So we can actually go inside and follow the logic of the while loop. Okay, so we're going to move next to current.next. Okay, so what that means is we're going to take the next pointer and we're going to set it to whatever current.next is pointing to. So current points to the node with value of 1. So current.next is the same thing as saying node1.next. And that is node 2. So the .next property of this node is pointing to 2. So that's what we're setting next to. Alright? Now, we're going to set the next pointer of current to point to previous. So again, current points to node with value of 1, and we're setting the next pointer, represented by this arrow, to previous. Okay, so current.next is the same thing as saying node number 1.next, which is this arrow. And we're going to set that equal to the value that previous is pointing to, and previous right now is pointing to null. So we're going to take this arrow and swap it around so that it points to null. Okay, so this is the first flip, if you will, of the nodes, or the reversal. Okay? So now that we've done that, we're going to move the previous pointer to point to current. So we're going to say in the code previous equals current. But really what this is saying is previous and current are both pointing to a node with value of 1. Okay? Then we're going to move current to point to next. So current points to next. Okay? I'll move this up a little bit. Okay? So now we've got the previous pointer pointing to node number 1, and both next and current pointers are pointing to node with a value of 2. And now we're going to repeat. So we're going to check our condition again. Is the current pointer pointing to null? It's not. It's pointing to a node with value of 2. Okay. So now we can move the next pointer to point to current.next. Again, next is over here. Right now it's pointing to node number 2. We want to point it to current.next. Well, current is also pointing to node number 2. So node number 2.next is pointing to 3. So we're going to move next over to point to node number 2, or number 3, I'm sorry. Now, let's set the next pointer of current to point to previous. So the dot next of current, which is the same thing as node with value of 2. So this arrow is going to go and point to node number 1, which is what previous is pointing to. Now we're going to move previous to the position of current. Okay? So both previous and current pointers are pointing to the node with a value of 2. Then we're going to move current to point to the same node that next is pointing to. Okay? And that ends that iteration. So now let's again check our condition. Is current pointing to null? It's not, so we can continue iterating. So let's move next to current.next. So current is node number 3. Current.next is actually pointing to null, so we'll move next to null. Then we're going to set the next pointer of current to point to previous. Okay, so that's this arrow, because current is pointing to this node right here. So let's rotate that around. So dot next of 3 is now pointing to 2. Now we're going to move previous to current and move current to next. Okay? So we're going to try to repeat this, right? We're going to evaluate our condition, traverse singly linked list while current is not pointing to null. Well, happens that current is pointing to null. So that means we can't do any more iterations. So we break out of our while loop, okay? And now we move to step number 4. In step number 4, we're going to declare a temp variable and assign it to point to head. So just to make it a little clear as to what we're doing, right? Remember that final condition that we're trying to achieve. So we're actually almost there, yeah? We've got the dot next pointers of the nodes reversed. So 3 is pointing to 2, which is pointing to 1, and 1 is pointing to null. The only thing we have left is we have to switch the locations of head and tail, right? Because we want tail, which is right now still at 3, to point to 1, and head, which is at 1, to point to 3, okay? So that's what these 3 steps are going to be doing, 4, 5, and 6. So let's declare a temp variable and assign it to point to head. So I've got this temp variable here represented by this diamond, and it's going to point to this dot head. Okay, so both temp and head are pointing to this node with value of 1. Now we're going to set head to point to tail. So essentially what we're doing is we're moving this guy over here. So head and tail now point to number 3, but we still have we're still keeping track of node number 1 because we created this temp variable which points to it. Okay, if we didn't have that here, as soon as we reassigned head to point to tail, we would have lost this node. We wouldn't be able to find it. We'd have to retraverse the array in order to find it. So that's why we made that temp variable, just to keep our place in line, if you will, and make sure that we don't lose track of this node. So once we set head to point to tail, now we need tail to point where head used to point. See? And all we have to do is say, hey, I'm going to point tail to where temp is, because temp was pointing to where head originally pointed to. So temp, tail equals temp, equals node number 1. And now we're done. Congratulations. We have successfully solved the reversal process of a singly linked list. We have our head pointing to node number 3, our tail pointing to node number 1. Node number 3 points to node number 2, which points to node number 1, which points to null. So we've successfully reversed the linked list. Thank you very much for watching. I hope you enjoyed it, as well as got something useful out of it. Okay, bye.